I know there's been a lot to this section, and we're finally to our last video. We learned in previous section about taking the value of a function, say we know that sine of something is 12/13, and we could from that derive all of the other trig function values. That was with a right triangle. Now that we've moved on to any angle, we can look at doing the same process but broadening it to include anywhere on the grid. When you're given a value for one of your trig functions, such as sine theta equals -2/3, you're going to have to be given a range or something else. In this case, they tell us that it is between 180 and 270, meaning it's down here in the third quadrant. We have to have that knowledge somehow. Sine we know is based on the y values, so automatically by it being negative we know it has to be the third or the fourth, but we can't make accurate representations for cosine and tangent unless we know what quadrant we're in. Another way that you might see this is they could have told us that sine of theta is -2/3 and tangent theta is less than 0. That's another way. Or sometimes they would have just said sine of theta equals -2/3 and we are in third quadrant. So that's different ways they can tell us which quadrant we're in. Now sine, we remember, is y over r, or b over r is the way your book describes it. So if we draw an angle, the r would be the distance, that would be this hypotenuse. The y value will be the -2, and we'll have to come up with the x value. And again, this is a right triangle, so it's easy enough to do. 3 squared equals -2, the quantity squared, plus x squared. So 9 equals 4 plus x squared. X is going to be, now we start looking at positive and negative. X could be either positive or negative square root of 5. Because we know it's in the third quadrant, that tells us we have to use the negative. So we'll ignore the positive option, and we have that x is the negative square root of 5. From that we can derive all of our other functions. Cosine theta is going to be x over r, so that'll be negative square root of 5 over 3. Tangent theta will be y over x, or -2 over negative square root of 5, which the negatives can be divided out, and we rationalize our denominator, we get 2 square root of 5 over 5. Secant theta will be the reciprocal of cosine, so that would be -3 over the square root of 5, which rationalized becomes -3 square root of 5 over 5, I should say rationalizing the denominator. Cosecant theta be the reciprocal of sine, that's easy enough, -3/2. And finally cotangent theta, that's going to be the square root of 5 over 2 once the negatives have divided out.